Alright, a few people have asked me to re-record my video where I derive the OLS formulas, and after looking at that video, I agree. So here goes. Hopefully this will be a little clearer and a little cleaner presentation. So the OLS formulas, ordinary least squares, what you're trying to do is minimize the sum of the squared residuals. So you want to minimize the sum of the EI's, the residuals, squared. And so whenever you want to minimize this, this is really the foundation of where everything else comes from. So just to review a little bit of notation, the EI is the residual. And what is the residual? Well, a residual is, we can rewrite this as the same basic thing here as minimizing the sum of the residual is the yi, which is each actual observation, minus the y hat I, which is what the equation that we are going to estimate is going to predict, squared. So this is just rewriting the residual as the yi minus the y hat, or the actual data minus the predicted value. Now, we need to substitute again, and substitute in what is the y hat I? Well, how you get these predictions are that the y hat I is going to be equal to your estimated y-intercept plus your estimated slope times your xi. And so what we're going to do is plug in, substitute this in for yi. And what that's going to look like is minimize, and there's basically a lot of substitution that goes on in here and a lot of simplification. That's really all the trick to this. So we're going to minimize the sum of the yi, so that's coming from right up here, minus the y hat I. So we're going to substitute that in. Beta hat 0 plus beta hat 1 xi. And this is subtracting this expression, and so you're going to want to distribute that minus sign through. So minus b0 minus b1. So I'll just go ahead and do that here. So minus beta hat 0 minus beta hat 1 xi and squared. Okay? So now that we have our basic expression that we're going to work with set up, in order to minimize anything, we're going to use calculus, and we're going to take the derivative of this expression. And the OLS formulas are going, what we want to do is figure out what formula will, what value of B0 will minimize this, and also what value of B1, or beta 1, will minimize this expression. So in order to minimize this with respect to two variables, we have to take two derivatives. So let's take the derivative of this expression with respect to both of those variables. So B0 or beta 0, what we're going to get is multiply by the 2 and then times the sum of the expression here that we get, yi minus, and forgive me, I'm not going to write hats on all the betas here. It's understood that that's really what the proper notation would be, but yi minus beta 0 minus beta 1 xi, and then basically we're using the chain rule here. And so what you're doing is you're multiplying this expression by the exponent, and then you have to take the derivative of the expression with respect to the beta 0 on the inside, and that derivative is minus 1. So technically we're also going to have to use the chain rule and multiply this by minus 1. And we're going to set that derivative equal to 0. And that's to try to find a minimum. Where the slope is 0. So now let's go ahead and clean this expression up just a little bit. Because this expression is equal to 0, we can go ahead and, let me use a different color here, We can divide both sides by 2, and that will get rid of the 2. We can divide both sides by -1, and that will cancel out the -1. So this is a little bit simpler expression to work with here. Now, let's go ahead and take the derivative of this expression with respect to beta 1. So derivative with respect to beta 1. And we're going to get basically the same kind of thing. We're going to multiply by the 2, and then we're going to get the sum of the yi minus beta 0 minus beta 1 xi. But then when we use the chain rule to take the derivative of the inside of the function and multiply by it, we're going to get minus xi. So minus xi. Set it equal to 0. Now let's go ahead and clean this function up just a little bit. We can divide both sides by 2, again, just like we did. And when I'm done here with this video, I will make a PDF of this and I will put it on berkeyacademy.com under the Files section so that you can download it and have it. And I will name this file something like OLS derivation.pdf. Okay? How about OLS derive.pdf? Sorry, I've been wrestling with my computer all day to try to get it. OLS derive.pdf. So you'll know how to find that file. Just click on the file section on the left-hand side. Okay, so we've cleaned up the 2, and another thing that I'm going to go ahead and do just to simplify this a little bit is, this is really like -1 times xi. I'm going to divide both sides by -1 so that I can get rid of that minus sign there, okay? So let's cancel out the minus sign. So now we've got this expression times xi equals 0. So we have our 2 derivatives, and what we want to do is simplify these, and basically what you want to do is solve this equation for one of the 2 variables, b0 and b1, and then substitute it into the other equation. And it turns out in this case that the easier one to solve for is to take this equation right here, the first one, and to solve it for beta 0. So let's work with that equation. And we're going to simplify and then solve for the y-intercept equation basically here. So what we do is we need to, it's easiest to see what's going on if you distribute the summation sign. So we can say sum of the yi's minus the sum of the beta 0's minus the sum of the beta 1 xi's. And so let's distribute that. So the sum of the yi minus the sum of the y-intercepts minus the sum of the slope times the xi's equals 0. And let me move this down a little bit so we have a little more room to work. Let's go ahead and move this over to the right-hand side. So let's add the sum of the beta 0's to both sides, and then perhaps what I'm talking about will make a little bit more sense. So equals the sum of the yi's minus the sum of the beta 1 xi's. Okay? So now we need to simplify this. The sum of the beta 0's, as I said before, is n times beta 0. You're just taking a number and you're adding it up n times. Equals, now again, let's just leave that the way it is for now. It would be an easier way to see what's going on. And then the sum of the beta 1 xi's. So what we're going to do now is we're going to divide everything by n so that we can get an expression that's just beta 0 on the left-hand side. So now when we simplify this, you can see that the n's cancel here, and we're just going to be left with beta 0. Here, actually, just to make this a little bit easier for what we're going to do later on, let me go ahead and simplify this over to the right here. So we're going to end up with beta 0 equals. Now, if we add up all the yi's and divide by n, we're going to end up with y bar, the average of the y's. Okay, and then, sorry, this should be a minus sign there. And then similarly here, if we add up all the xi's and divide by n, we're going to end up with the average of the x's. And this b1 is just kind of a multiplier. So you can think about this as, we could rearrange these two terms, b1 times the sum of the xi's over n. So that is minus b1 times the average of the x's, because we're adding up all the x's, dividing by n, and then we're multiplying all of that times b1. So this is the equation to calculate the y-intercept. That was the easy part. Now, to get the slope formula, it's a little more complicated and quite a bit more involved, but we have our first part of our solution now. So what we're going to need to do, just like solving for any two equations in two unknowns, you want to take your two equations. We have taken one of our equations and solved it for b0. And now what we want to do is plug this expression back into the second equation for b0. So we're going to take this b0 here and we're going to substitute in y bar minus b1 times x bar. So let's see what happens when we do that. So let's try to keep, I want to try to keep both of those things visible at once here. Okay, I think barely you'll be able to see that. Okay, so now let's take this equation and substituting in for b0, what we're going to end up with is the sum of yi minus, all right, here in brackets, we're going to substitute in for that b0, y bar minus beta 1 x bar minus beta 1 xi, and then that whole expression times our xi there is equal to 0. And everything we're going to do now is just a series of 4 or 5 different simplifications. So let's get started. So the first thing I'm going to do is I'm going to multiply everything through by this xi term, because we're going to have to distribute it to each of the terms that are inside the parentheses here. So let's move down so we have some room to work here. So that's going to look like this, the sum of yi times xi minus, and then here we're going to have y bar minus b x bar, sorry, beta 1 x bar times xi minus beta 1 xi times xi equals 0. Now, in the next step, what we're going to do is collect some terms together that we're going to be able to simplify in some interesting ways here in just a second. So what I want to do is I want to collect this yi times xi and this y bar times xi, right? So when we multiply that through, and I'm going to write that this way. And I'm also, at the same time, let's distribute the summation sign. Well, now let me not do too much at once. Let's do this before we start collecting things. I think this is where a lot of people get confused. So let's do two things here. I'm going to distribute the summation sign, And I'm going to expand this term by multiplying the y bar by the xi and the b1 x bar times the xi. Okay, so let's just do that one step first here. So when we do that, we're going to end up with the sum of the yi xi, so that's just that first term, minus the sum of the, now I'm going to distribute this, y bar xi, and now this is minus a minus beta 1, so that's plus beta 1 x bar, beta 1 x bar times xi, and then minus beta 1 xi times xi. Okay, and sorry, I should have distributed the summation sign there, so let me sneak it in between these. Okay, and minus the sum of the beta 1 xi xi's. So now we want to collect some terms that we'll be able to simplify. And this is the most mysterious part to most people, why we're going to do these collections the way we do, but let's go ahead and do it, and then I'll explain why we're going to do it. So we're going to sum, I'm going to collect, let me use green here, I'm going to collect this and this. And I'm going to rewrite it this way. The sum of the yi minus y bar times xi. Okay, so I've just collected those two terms, and if you distribute that back out, you'll get those two terms back out of it. Then the next term is I want to collect these two terms right here. Let me highlight those in pink, just to kind of simplify things a little bit and make it look a little bit nicer, and it'll help us simplify the sum of the beta one times xi minus x bar times xi equals 0. Okay, so now we just have two terms, and now what we want to do is try to simplify those things a little bit. So now our job is just to take this final expression and rewrite it so that it looks like what we're used to seeing in a standard slope estimator formula for a simple regression. And the first thing I want to do is to rewrite this. I just want to switch these two terms. Since the B1 is a constant, it's just multiplying everything by the same number, we can bring it outside of the summation sign. So let me do that real quickly here. So let me just erase that and bring that to the inside, sorry, to the outside of the summation. So sum, so beta 1 times the sum here. And then to get it to look like the standard formula that we're used to, we need to realize that this term over here can be rewritten this way. It can be rewritten as the sum, so this term right here is the same thing as the sum of the yi minus y bar times xi minus x bar. Now, how in the world could those two expressions be the same thing? Let me underline them each in orange here so that it's clear what I'm talking about. How this is true and how you can see this is if you just multiply this equation out. So we have two terms here multiplied by each other. We can use the FOIL method to multiply them out and watch what we get. Multiply the first two terms, so we get the sum of the yi times the xi, so yi xi, and then do the outer terms, yi x bar, so that's minus the sum of the yi x bar, and do the inner, so that's minus the sum of the y bar xi, and then the last term. So that's two negatives, they make a positive, so plus y bar, sum of the y bar x bar. So plus the sum of the y bar x bar. Now, the thing to notice is that this term, the sum of the yix bar, and the last term, so this is negative and this is a positive sum of the y bar x bar, these two terms will cancel with each other because this is a negative and this is a plus, and this term is the same as the sum of the yi's, right? So the sum of the yi's is the same as the sum of the y bars. How do you know this? Well, if you have three numbers that average to 10, say 5, 10, and 15, right? So suppose the three numbers are 5, 10, and 15. The average of those numbers is 10. If I add up the yi's, I'm going to get 5 plus 10 plus 15 is 30, so that's the sum of the yi's. And that's the same as adding up the average three times, 10 plus 10 plus 10. Right? So these two terms are the same, and so they can cancel. And so what are we left with? We're left with the sum of the yixi minus the sum of the y bar xi, and that's really what we have right here, okay? So this term is a familiar part of calculating a slope formula, and so this is the reason why you can do that. So let me move this out of the way. I'm going to move it down to the bottom of the worksheet here so that you can see that, but let me move it so that we can now simplify the right hand side here. So this term basically becomes rewritten like this. Oh, let me get my pen going here again. And now we need to rewrite this right-hand term. And we're going to use a trick that is almost identical to what we just did before. We can rewrite the sum of the xi minus x bar times xi this way. So this equal sign here, let me see. Okay, let me get the right color. Equals, so beta 1 times the sum. Xi minus x bar times xi is the same thing as xi minus x bar times xi minus x bar. And to demonstrate that, you can do exactly the same thing we did before. Just multiply these terms out, and then you'll be able to see that two of those terms cancel, leaving us with exactly the same thing here, okay? And now we're basically done. All we have to do is now actually solve this equation for beta 1 in a little bit more familiar way. So let's just, in order to do that, we're just going to divide both sides by, the sum of the xi minus x bar times xi minus x bar. Now this, you'll notice, is xi minus x bar squared, since those two terms are the same thing. And so by dividing both sides, we're going to end up with our familiar beta 1, and now I'll add the hat again. Our estimator for the slope that minimizes the sum of the squared residuals is the numerator, the sum of the yi minus y bar times xi minus x bar divided by, that's ugly there, divided by the sum of the xi minus x bars squared. And now we're done. We have our equation that tells us how to calculate an estimate of the slope given our data, and we have our other equation that tells us how to figure out what the y-intercept is for the equation, and we're done. So hopefully that did a little bit better job. I had more time this time. When I made the other video, I was limited to 11 minutes. I've made this longer so that I can go through it a little bit more slowly and show you each of the steps, hopefully a little bit more clearly. As I said again, I will print this out as a PDF and I'll put it on berkeyacademy.com. And again, I'll call it olsderive.pdf if you look at the files section over there. So if there's any mistakes I've made or anything that's not clear, please, as always, leave me a comment or question in the section below. And otherwise, good luck in your studies.